way of graphing parabolas, we're going to take a look at a couple more examples. We're going to take a look at number 6, number 10, and number 12. So let's get rocking and rolling, shall we? First thing we're going to do is identify A, identify B, and identify C. All right, so in this equation I have A, which is the number in front of x squared. B is the number in front of x, which there is no x term there. And then C is the constant all by itself. Remember, if anything is missing, if any of these terms are missing, we're going to add them in. So this is going to be 2x squared plus 0x minus 1. So again, A is the number in front of x squared. B is the number in front of x. If it's not there, put it in. And C is the constant all by itself. So let's see, A is 2, B is 0, C is negative 1. So far, so good. Let's take a moment and think about what this graph is going to look like. Well, A is positive, which means it opens up. It is not a fraction, so it's not fat, and it's not 1, so it's not normal. The only other option is skinny or narrow. And since it opens up, our vertex is going to be way down at the bottom in the valley, and it's going to be the minimum value. So let's go ahead and use our formula to find the first part of our vertex. Negative b over 2a. Negative b is 0. 2 times a, which is 2. So this is going to be just 0 over 4, which is 0. 0. That means our axis of symmetry will also go through x equals 0. Now, let's find the other half of our vertex. We're going to take this 0, and we're going to plug it into our original equation wherever we see an x. So instead of this x here, I'm going to have a 0. Watch. Y equals 2 times 0 in parentheses squared minus 1. It's the same equation. I just used a 0 instead of an x. And 0 squared is 0 times 2 is 0 minus 1. Minus 1 or negative 1 is our y value. So our vertex is at 0, negative 1. Let's go ahead and plot that. 0 on the x, negative 1 on the y. Cool. Our axis of symmetry goes through this spot on the x-axis as well. So in order to find some points that we can plot to create this parabola, we're going to start at our axis of symmetry and we're going to go to the right 2 spaces. So let's see, we're going to go over 1, which is x is positive 1, and then we're going to go over 2, x is positive 2. So these are the 2 places that we're going to check to find points for our parabola. We're going to plug these values into our original equation to see where the point will lie. So let's see. If we have y equals 2 times 1 squared minus 1. Well, 1 squared is 1, times 2 is 2, minus 1 equals 1. Okay, so we should have a point at 1, 1. So let's see, 1, 1. There's my point. And that fits with my projection that this parabola would open up and that it would be a skinny parabola. What if I check x equals 2? Let's do y equals 2 times, instead of x, I'm going to plug in a 2 in parentheses, squared minus 1. Well, 2 squared is 4, times 2 is 8, minus 1, and that is 7. Whoa. All right, so let's see. I'm going to go over 2 and up 1, 2, 3, 4, 5, 6, 7. Again, this is a parabola that's opening up, and it's pretty skinny, so that fits with what I thought it would be. Now it's time to reflect these points over that axis of symmetry. This is what makes parabolas awesome. This is 1 space away, so I'm going to go 1 space away, and there's a point. This is 2 spaces away, so I'm going to go 2 spaces away, and there's a point. Ta-da! Now I can connect all of my points with a nice, smooth curve. And there you have a parabola. Let's take a look at number 10 on the next page. Same as before, we're going to start by identifying A, B, and C. And I can tell from this quadratic, since there are 1, 2, 3 terms, that nothing is missing. So let's see, A is in front of the x squared. There's nothing there, which means it's a 1. No problem. B is in front of the x term, the middle term, that's a 4, and C is the constant by itself. So let's see, A is 1, B is 4, and C is 6. Cool. So A is positive, which means this opens up like a smiley face. A is 1, which means this is a normal graph. It's not going to be very wide or very skinny. And since it opens up, my vertex is going to be a minimum value. Let's find that vertex using our formula for the x value. That means our axis of symmetry also goes through -2. But we can't plot anything yet. We need to find the y value for the coordinate. So I'm going to use this original equation, and instead of x's here, I'm going to plug in -2. So my vertex is at -2, 2. -2, oh, I went positive again, gee whiz. -2, +2, so right there. And that's going to be the lowest point of my vertex. Now it's time for me to find some more points. So I know my axis of symmetry cuts right through this spot, okay, because the axis of symmetry always goes to the vertex. So starting at my axis of symmetry, I'm going to go over one spot, that's -1. And then I'm going to go over 2 spots, that's 0. So these are the 2 values that I'm going to plug in to find more points. So this is over 1 space. This is going to be over 1 space. This is over 2. This is over 2. There's a point. I have 5 points. Now I can connect them with a nice, smooth, rounded curve. And I have my parabola. All right? Well, let's take a look at one more. Number 12. I want to find A, B, and C. All right, A is in front of x squared, right here. There's no number, so I know that this is actually a 1. Cool. B is going to be in front of the x term in the middle. That's going to be +8, and my C is my constant at the end. So just to fill these in, A is 1, B is 8, C is 19. Now I can use all those values to think about this parabola. A is positive, so it'll open up. A is 1, so it's normal. And since it opens up, my vertex will be a minimum down at the bottom of that valley. So let's find our vertex using our formula, -b over 2a. My vertex begins at -4. The axis of symmetry will be at -4. Now I need to find the other half of my vertex. So I'm going to take this value, this -4, and I'm going to plug it in to this equation. Should have gotten y equals 3. Is that what you got? I hope so. If not, pause the video, take a look at the steps that I took, and see where you went wrong. Maybe it was a simple math mistake, no big deal. If you did get it, let's keep going. So our vertex is at -4, 3. So I'm going to go -1, 2, 3, 4, and up 1, 2, 3. So there's my vertex. Okay, that's going to be the lowest point of my very normal parabola that opens up. Now I need to find 2 more points to test. So I put in my axis of symmetry, and I'm going to go to the right 2 points. So if I go this way once, then that puts me at, let's see, yeah, so that's at -3, and then I go again, and that's -2. So these are the points that I'm going to test in my equation to see where the point will lie. Awesome. There's my points. Now I just have to reflect them over my axis of symmetry. So it's 1 spot away, so I'm going to go 1 spot away on the other side. This one is 2 away, so I'm going to go 2 away over here. And I know a lot of these have been following that same pattern of 1 away and then 2 away. They won't always be like that, so don't think that that's significant. It doesn't really matter how far away from the axis of symmetry it is. It'll always reflect over to the other side. These just happen to be working out that it's 1 away and then 2 away. So I hope you had fun graphing parabolas with me. Finish the rest of these up on your own and come on to class ready to discuss what you found.